Good afternoon. Well, I believe you are in a perfect state of health. So for today, I want us to talk about the parabolic function, which is also called the quadratic function. For today, we'll just focus on sketching this function. Okay, but before we do so, let's cover some basic aspects. So you need to know that we have two forms, the standard form and the turning point form. Of course, we have the intercept form, but for now, let's focus on the first two. So this is the standard form. F of x equals ax squared plus bx plus c. And then the turning point form is going to be f of x equals a into x plus p. And then you say all squared plus q. So let's talk. What does each of these mean? In both of these equations, the value of a is going to tell us the shape of the function. That's what you must know. So what do I mean by the shape? If the value of a is negative, then you should know that the function is going to be convex. But if the value of a is positive, then the function is going to be concave, like that. That's fine. Then we go to P. So P is going to tell you three things. The first thing is going to tell you about the horizontal shift. By how many units did we move this graph, either to the left or the right? So it's a horizontal shift. It's also going to tell you information about the x coordinate of the turning point. And it's also going to tell you information about the axis of symmetry. So that's what you should know. Perfect. So what about Q? This Q is just going to be the y coordinate of the turning point. That's what you must know. But you need to know that Q, it is also the vertical shift. By how many units did we move this function up or down? So that's the value of Q. Now, to be specific, if we look at the last two here, how do we find this x coordinate of the turning point? Then you know that we take what is inside the square, which is x plus p, and then we equate this to 0. So it means the x coordinate of the turning point will just be negative p like that. So that's how you find it. Fine stuff. So what about the axis of symmetry? What is this axis of symmetry? So you need to know that the axis of symmetry, it's a line that's going to cut your graph into two equal parts. That's what you must know. But you also need to know that the axis of symmetry passes through the x coordinate of the turning point. So as a result, this x equals negative p is going to be the equation of the axis of symmetry. Fine. Now, what about C here? C is just going to be the y-intercept. It's not a vertical shift. It's not what? It's just the y-intercept. Okay. Yeah, I think we did cover enough basic aspects. So let's go and do the real thing. Remember what we said. We said for today, we want to focus on sketching. So these are the things you need to worry about every time you must sketch. You need to know the shape of your function. How is the function going to look like? You also need to know the intercepts with the axis. So what is going to be the x-intercept and what is going to be the y-intercept? Now you need to know the coordinates of the turning point, and then you need to know the equation of the axis of symmetry. So these are the things you need to know, and then you can sketch. Now this is the function we must sketch. They say f of x equals x squared plus 4x, then you say minus 12. So the first thing we see here is that the value of a is going to be 1, and 1 is a positive number. So because a is positive, we are expecting a function that is concave like that. That's fine. So we are done with the shape. We come to the intercepts. So we know that for the y-intercept, we let x to be 0. So let's go. It means our y-intercept will just be 0 squared plus 4 into 0 minus 12. So it's going to be negative 12. But in coordinate form, it's where x is 0 and y is negative 12. That's fine. What if we must find the x-intercepts? So for x-intercept, we need to let y to be 0. So in this case, we told you that every time you see f of x, you actually see y. So it means where you see f of x, you'll just put 0 when you must find the x-intercepts. And then after doing that, you realize that this is now a quadratic equation. So how do you solve for a quadratic equation? You need to factorize it first. Then you can use the 0 factor law. So here you will tell them that factors of x squared are going to be x and x. Then we go to the last term. We are looking for factors of 12 such that if we either add or subtract, we must get 4. So in this case, we must use 6 and 2. 6 times 2 is 12, but 6 minus 2, it's going to be 4. So we know that the bigger number must take the sign of the middle term. Then here we apply the 0 factor law. X plus 6 equals 0, or x minus 2 equals 0. So this means that the first x-intercept will be negative 6, and the second x-intercept will just be positive 2. In coordinate form, this is going to be negative 6 and 0, but this one is going to be 2 and 0 like that. So we are done finding the intercepts. After finding intercepts, we need to find the coordinates of the turning point. So how do we do that? It's a little bit difficult to find the coordinates when it is in standard form. So the first thing we want to do is to convert it to the turning point form. So how do we do that? The best way to do that is to complete the square. Well, we actually have 2 methods for finding the coordinates of the turning point. So let's start with the most demanding, which is completing the square. And then we can use a formula now that we know how to complete a square. That's fine. So what is the procedure? Every time you must complete the square, you need to make sure that the coefficient of x squared is 1. If it's not 1, you take the coefficient out as the highest common factor. Remember that. But in this case, since it's going to be 1, we don't take anything out. So we write the x squared and the 4x like that. But after doing this, we say plus. We open a bracket. We say 1/2 multiplied by the coefficient of x. And then we square this. Then we say minus 1/2 multiplied by the coefficient of x. We also square it, and then we say minus 12. So we add it and subtract it at the same time, because the result here is actually 0. So it's like you did nothing. You didn't change the equation in any way. That's nice. So after doing this, we simplify. You're going to have x squared plus 4x. Half of 4 is just going to be 2. And then you say minus 2 minus 12. Then from this point, you are going to take the trinomial there. Oh, it's actually not the correct trinomial. Why? It's because half multiplied by 4 is going to be 2, and then 2 squared is going to be 4. So I was supposed to say plus 4 and then minus 4. That's what I was supposed to say. Sorry about that. So it's just going to be plus 4, and then it's going to be minus 4. Now, after doing this, we take the first 3 terms. So what do we do with them? We want to factorize the first 3 terms, but the last 2 will just add them up. So negative 4 minus 12, it's just going to be negative 16. Coming to the first trinomial, we say what are factors of x squared? It's x and x. And then we go to the last term. What are factors of 4 such that if we either add or subtract, we must get 4? So it's going to be 2 and 2. 2 times 2 is 4. But 2 plus 2 is going to be 4 again. So it means both of these factors, they need to be positive. So that 2 plus 2, you get the middle term, which is 4. The whole point is to achieve 2 brackets that are exactly the same. Why? So that we can take it once and then we square it. Then we say minus 16. So if it's like this, then it's in the form a into x plus p all squared, and then you say plus q like that. There has to be a square there. Okay, that's fine. So from this point, remember how we said we find the x coordinate of the turning point. We said it's going to be x plus p, which is equal to 0, meaning your x is going to be negative p. So we apply the same reasoning. So we are looking for the x coordinate of the turning point. Therefore, we'll say x plus 2, which is equal to 0. So this means that the x coordinate of the turning point is going to be negative 2. But if you remember what I said to you, the 16 is going to be q, right? The negative 16. It's the value of q. And I told you that the value of q in this case, it's going to tell us the y coordinate of the turning point. So this means that the coordinates of the turning point are just going to be negative 2 and negative 16, like that. So after finding the coordinates of the turning point, what is left is to find the equation of the axis of symmetry. So remember what I said to you. I said the axis of symmetry passes through the x coordinate of the turning point. And therefore, its equation, it's just going to be x equals negative 2. So we have everything we need now. The shape of the graph, we know it. The intercepts with the axis, we know them. We know the turning point. We have the axis of symmetry. So there's nothing stopping us from making a sketch. So let's go. Yeah, we'll just erase this part. So this is our nice Cartesian plane, like that. So we said the value of a is positive, therefore the function must face up. But we said the turning point is going to be at -2 and 16. Then we said the y-intercept is going to be -12. So maybe I might want to extend it a bit. That's fine. So assuming -2 is going to be here, then here I'm going to have a turning point like that. And then we said the x-intercepts were going to be 2 as well as -6. So it means my function is going to make a nice turn here. Yeah, it must turn nicely. Let's make sure it turns nicely. So it's going to cut the y-axis there, and then it's going to proceed like that, all the way to positive infinity. The same thing applies here. It's just going to be something that is nice like that. Then it goes all the way to infinity. But I know your function will be a little bit beautiful than mine. Yeah, I think it has to do with age. I'm a little bit old, guys. So as you age, you lose the ability to make nice sketches. So this is how your function is going to look like roughly. And then one thing we said, we are going to have the axis of symmetry. So for your axis of symmetry, it's up to you if you're going to use a solid line or a dotted line, but preferably use a dotted line. Yes, please use the dotted line when you go to the Excel. It's a please. It's an ask. So this is the equation of your axis of symmetry. You'll just tell them it's going to be x equals -2. Of course, you can use a black color for this. So you'll have your x equals -2, but your x-intercept, the coordinates are going to be 2 and 0. And then the coordinates here are going to be -6 as well as 0. So you said to me the turning point will be at -2 and -16. But you said to me the y-intercept will be where x is 0 and y is -12, like that. That's what you said to me. So this is just how it's going to look like. Of course, don't forget to label your axis, and don't forget to give your function the name. Tell them it's going to be f of x. Now, one thing you must also know is that the axis of symmetry is going to be halfway between your two x-intercepts. You need to know that. And even when you sketch, guys, do you see my sketch is not so nice? You can see that the distance from here to there is not exactly equal to the distance from here to there. So in your sketch, please make sure that the distances are going to be more or less equal. Perhaps we can try to fix it. Perhaps we can try to fix it. Otherwise, this is just the procedure you follow if you want to sketch. Yes, more or less. Yeah, I think it's a lot better now. Yeah, I think it's a lot better. Very better for that matter. Better to the power better. Okay, yes, so this is just how you can make a sketch of your quadratic function. So remember, I promised you that we can find a turning point using a demanding method, a long one. And then there's also a formula we can use to take us straight to the answer. It's a straight and forward formula. So you can say x equals negative b over 2a. So why do you use this formula? You use it when you must find the x coordinate of the turning point. Are you fine? Fine stuff. Remembering your standard form, we said this is going to be ax squared plus bx plus c. So you go into your formula. The value of b from the equation itself is going to be positive 4. And then you say 2 into the value of a, it's just going to be positive 1. So if you say negative 4 divided by 2, it's just going to be negative 2. So you found your x coordinate of the turning point. After finding the x coordinate, you must find the y coordinate of the turning point. So in order for you to do that, you must substitute this negative 2 into the original equation. Like that. So negative 2 squared, it's going to be 4. And then 4 times negative 2, it's going to be negative 8. And then you have minus 12 like that. So if you say 4 minus 8, it's negative 4. Negative 4 minus 12, it's just going to be negative 16. So you have your x coordinate of the turning point. Now you have your y coordinate. And if you have a look, they are exactly the same as the ones we found here. So it's up to you. Which one do you use? I think it makes sense for us to stop this session here. Thank you so much for paying attention, for watching the video. Please don't forget to like this video and subscribe to my YouTube channel if you haven't done so as yet. Okay, thank you so much. Let's see you another day.